Hello friends, welcome back to my channel. Today, as usual, we are going to solve another Maths Olympiad problem. I am sharing this technique to solve Olympiad inequalities, especially geometrical inequalities. I learned this technique a few days back, and so I thought to share this technique with you all. I learned the technique with the same problem that is displayed here. This problem is from This problem is from APMO, Asia Pacific Maths Olympiad 1996, and this was the fifth question of the paper. And this the level of APMO is quite similar to the INMO in India. So let's begin how to do it. Now let's begin with a fact. Suppose we have a circle, and this circle is the nth circle of some triangle. Now we know from any point exterior to a circle, the tangents are always of equal length. So if we assume this length to be x, so this length is also x. If I assume this coordinate to be b, this is y. So this little length from here to here is also y. If this is c and this is z, this is also z. So we can see that the side opposite to a is y plus z, to b is x plus z, and to c this x plus y. Hence prove that there always exist three integers x, y, and z such that the sides of a triangle are the sum of any two of these integers taken two at a time, any three of these integers taken two at a time. So this is the main procedure, main method behind the technique we are going to learn today, and that is known as the Ravi substitution. What does that tell, Ravi substitution? That in these sort of inequalities, we can substitute the side of the triangle. For example, let's suppose I want to say this length A. I use a different color. So the length, the length A equals, yes. So the length A means this length, the side opposite to a, b means this length, the side opposite to b, and c means this length, the side opposite. So a equals y plus z. Similarly, b equals x plus z, c equals x plus y. So this is the main motivation behind substituting the sides of triangles with sum of two variables in this way. And this is pretty useful in solving inequality problems, like we will solve in this problem, and I will give a assignment based on this principle too. Stay tuned for that. Now just we need to substitute these over here so that this problem gets a bit easier, a bit under our control, so as to solve it. Now let's begin. So if I raise this thing off, remember that the remember the pattern. Remember that it's like the tuples x y z below a b c. A equals the rest two, that means y plus z, except the one above it, that is x. B equals x plus z except the above one, that is y. C equals x plus y except the above one, which is z. So in this manner we can memorize how to write the length of the triangles. Now without further ado, let's come back to the problem. Now if I start this problem, this APM problem, this states that let A be, let A, B, and C be the length of three sides of a triangle. Prove that square root of A plus B minus C plus square root of B plus C minus of A plus square root of C plus A minus B is less than root A plus root B plus root C. And we have to determine when does this inequality occur. Now, what we will begin by, let's assume we will write by Ravi substitution. A equals y plus, I learned this technique few days ago, so I thought to share with you all. X plus z, c equals x plus y. Now let's substitute the values over here. So a plus b, that means a plus b minus c. So we will be left with a plus b, that is 2 times z, and rest all will cancel themselves. Similarly here, 2 times y, oh sorry, my mistake, x plus z and plus x plus y. Now we will assume this to be true, and we will get to something which we can prove very easily, and we will reverse engineer, we will reverse the process to arrive at this result, and that will be the way we will be proving this thing. So if you all know, I mean the RMS AMGM inequality, AMGM HM, the full name, inequality. This has a one line solution. Although I want you all to try this problem with AMGM, that would be more interesting. In this video, I will be solving using this to RMS and RMS AM inequality. So let me write the statement of this thing first. What is this RMS AM inequality? Now, RMS AM inequality states that if we have n variables and we take the square root of the sum of squares of the all the variable dot plus x n square over n, this would always exceed the average of these two numbers, or the am of these all n numbers. This is the RMS AMGM inequality. So we can do this very simply. That is, we will take n equals 2 at a time. See how I progress. Now what I will do is I will assume the x1 to be root of y plus root of x whole square over 2 is greater than root of x plus root of y by 2. This is just another form of AMGM. You can work it out. This would become x plus y by 2, and this, after squaring x plus y by 4, this becomes, indirectly it will lead you to x square x plus y greater than 2x root xy. So this is fairly a bit easy one, a short one. That's why I used it. You can solve it easily using AMGM too. Try it out yourself. Now this is the first equation. Similarly, we can have for x and y. So symmetrically, we can easily write that if I write this result, we can directly write all of this as taking yx, taking xy, and taking yz, two at a time, 3 times. We will land to the result that this is the whole square root x plus z by 2 plus y plus x, x plus z, y plus greater than root of x plus root of y plus root of z times 2 over 2. This 2 to cancel. This root 2 goes to this side, and we will clearly be proving this thing. This thing will lead you to this thing, and we can reverse engineer to reach back our process. So this was a simple method to prove this. Now this method is known as Ravi substitution. Now I want you all to do a similar problem yourself. Let me share the problem with you all. So here is the problem. Now this is an international mathematical olympiad problem. This was the sixth problem of the 1983. You can see this. I have both white formats and black formats. With the length of side of a triangle. Prove that a square b into a minus b plus b square c into b minus c plus c square a into c minus a greater than 0. Indirectly, if I write in cyclic notation, it is asking us to prove cyclic over a comma b comma c a square b times a minus b greater than equal to 0. And we have to also determine when this inequality holds. That means when does this equal to 0 or this sum. So try this problem yourself, the previous one too, before watching the solution, and hope you liked it. Stay tuned for more such videos. Thank you. I hope you enjoyed.